Hi guys, this is the EdExcel GCSE Maths Paper 2 from the higher tier from the November 2019 series. So let's get straight into it. We have here for question 1 the table which shows some information about the weights of 50 potatoes, and we've got the weight in grams and we've got the frequency. And Evita draws this frequency polygon for the information in the table, and the frequency polygon is not fully correct. We have to write down two things that are wrong with the frequency polygon. So there's no frequency label that's along this axis here, and also the frequency polygon should not be closed. They closed it by joining them up with a straight line. For question 2, the length of a pencil is 128 millimeters correct to the nearest millimeter, and we have to complete the error interval for the length of the pencil. Well, here we have to consider our lower and upper bound. So we have 128 millimeters, and then we plus and minus 1/2 of our unit. So our unit here is 1 millimeter. So the range of values, we have 127.5 and 128.5. So the error interval, we have 127.5 and then 128.5. Question 3. Tom and Adam have a total of 240 stamps. The ratio of the number of Tom stamps to the number of Adam's stamps is 3:7, and Tom buys some stamps from Adam. The ratio of the number of Tom's stamps to the number of Adam's stamps is now 3:5. How many stamps does Tom buy from Adam? You must show all your working. Well, the situation before, so just write this down before. Well, you can see we have 3 plus 7 parts here. So here you can see we have 10 parts. And we can find out how many stamps Tom and Adam had before with this. So we have 240 stamps in total. So 240 divided by 10, that's equal to 24. So here we have 24 stamps per part. Okay? So Tom, he would have 3 multiplied by 24, which is 72. And Adam, he now has 7 times by 24, which is 168. That's the situation before. And after, well, we have here 3 plus 5 parts. So here we have 3 plus 5, which is 8. So now we have 8 parts. So 240, that's not going to change. So 240 divided by 8, that's equal to 30. So now we have 30 per part. And Tom now has 3 times by 30, which is 90 stamps. And Adam now has 5 times by 30, which is 150. So you can see here the number of stamps Tom buys from Adam. You can see here Adam has lost 168, take away 150, which is 18 stamps, and Tom has gained 90 take away 72. So 90 take away 72 is 18. So Adam has lost 18 stamps, Tom has gained 18 stamps. Okay, so now for question number 4. Each person in a fitness club is going to get a free gift. Stan is going to order the gifts. Stan takes a sample of 50 people in the fitness club. He asks each person to tell him about the gift they would like. The table shows information about his results, so we've got the results here. And there are 700 people in the fitness club. We have to work out how many sports bags Stan should order. So to work this out over here, we've got a sample of 50. And of those 50, you can see here, 17 wanted a sports bag. So the proportion of those who wanted a sports bag is 17 over 50. There's 700 people in the fitness club. So 17 over 50 multiplied by 700, if we work this out, 17 divided by 50, and then multiply this by 700, it turns out we get 238. So there's 238 people who want a sports bag. And then for the next part, we have to write down any assumption you made and explain how this could affect your answer. Well, here we can see that the sample is representative, otherwise our answer would be wrong. Okay, so now for the next question, we've got 6 graphs shown here, A, B, C, D, E and F, and we have to write down the letter of the graph that could have equation. For the first part, y equals x cubed. That's quite obvious, that's graph F. So here we have graph F. And then part B, y equals 1 over x. Clearly that's graph D over here. Okay, so hopefully that answers that. And now for question number 6, the nth term of a sequence is 2n squared minus 1, and the nth term of a different sequence is 40 minus n squared. We have to show that there is only one number that is in both of these sequences. This is a bit of a difficult question, but I think the best way to go about this question is to list the first couple of terms. So if we consider this 2n squared minus 1, we can use the table function in our calculator. So access the table function, type this function is, and list the first, say, 10 terms. Okay, and if we do that, we've got here 1, then we've got a 7, then we've got a 17, then a 31, then a 49, then a 71, then a 97, so let's just move this here, then a 97, then a 127, then here we've got a 161, here we've got a 199, and those are our first 10 terms. Let's now type in the 40 minus n squared. So our first 10 terms here, for the 40 minus n squared, we've got here 39, 36, 31, 24, 15, 4, minus 9, minus 24, minus 41, minus 60, and that's it for now. Okay, so with these we can continue working out the other sequences, but you can see here for the 40 minus n squared, the terms continuously decrease, and here the terms continuously increase for the 2n squared minus 1. And we're asked to show that there is only one number in both these sequences. The only number that's in both these sequences is this 31. So therefore, 31 is the only number in both the sequences. Question number 7, we have to work out 3.42 times 10 to the minus 7 divided by 7.5 times 10 to the minus 6, giving our answer in standard form. So if we work this out in our calculator, we've got 3.42 times 10 to the minus 7 divided by 7.5 times 10 to the minus 6. It turns out we get 0.0456. And we want to write this in standard form, and for standard form the number is supposed to be in the form a times by 10 to the power of n, where a is in between 1 and 10. So we need to move this decimal place 2 units to the right, so we end up with 4.56 times by 10 to the minus 2. Question number 8. The number of days d that it will take to build a house is given by d equals 720 over n, where n is the number of workers used each day. And Ali's company will take 40 days to build a house, and Haley's company will take 30 days to build the house, and Haley's company will have to use more workers each day than Ali's company. How many more? So for this question we can find out how many workers per day Ali uses and how many workers per day Haley uses, and finding the difference between those will answer the question. So if we consider Ali, D is the number of days it takes to build a house, and here N is the number of workers that are used each day. So D over here is equal to 720 over 40, so this turns out to be 18 workers per day. And if we consider Haley, so considering Haley, D is equal to 720 over 30, which is 24 workers per day. And therefore, the difference between these is what we need to work out. So 24 minus 18, that's equal to 6. So we have 6 workers per day. Okay. For question number 9, the diagram shows a cube and a cuboid, and the total surface area of the cube is equal to the total surface area of the cuboid, and Janet says the volume of the cube is equal to the volume of the cuboid. Is Janet correct? You must show how you get your answer. Well, because over here we have a cube, the dimensions over here of each length will be the same. So here we have an x, here we have an x, here we have an x. And the reason I say x is because we actually don't know the actual length of the cuboid, of the cube rather. Now with this over here with the cuboid, we can find out the surface area and then equate this to the surface area of a cube. So the surface area of the cuboid we have over here, if we think about it, we've got this front face here. This has area 6 times by 8, and then we multiply that by 2 because we've got the front face and the back face. So here we've got 2 lots of 6 times by 8. So this over here is the bit in red, and then here we've got the bit at the side. So we've got this side face over here, and then we've also got this other side face, so that has dimensions 18 with height 6. So we have 2 times by 6 times by 18. So this bit over here is the bit in blue, and we've also got the bit at the top, which I'll show in green, and we've also got the bit at the bottom. Okay, so here we've got 2 lots of 8 times by 18. So that refers to the bit at the top and bottom. So if we work out the surface area here, we've got 2 lots of 6 times by 18 plus 2 lots of 6 times by 8 plus 2 lots of 8 times by 18. It turns out here we get 600. So the surface area of the cuboid is 600 centimeters squared. And if we consider the surface area of the cube, well, we've got 6 faces in total, and the area of each face will be x times by x. So that's x squared, and this is equal to 600. And with this we can find out the length x. So if we solve over here, we have x squared equals 100, and therefore x is equal to 10. So what does this mean? It means here each side has length 10 centimeters. Okay? And with this we can find out the volume of the cube and the cuboid. So the volume of the cube, that's equal to x times by x times by x, in other words 10 times by 10 times by 10, which is 1000 centimeters cubed, and the volume of the cuboid, that's equal to, well here, 8 times by 10. So we have 6 times by 8, times by 18, and if we work this out, 6 times by 8 times by 18, turns out we get 864 centimeters cubed. And clearly these are not the same, so therefore we can conclude from here that Janet is incorrect. Okay. Question number 10, we have to make k the subject of the formula y equals the square root of 2m minus k. So first thing we need to do is get rid of this square root, and the way we can do that is by squaring both sides. So we have y squared equals 2m minus k, and we want to get k by itself, so we can add k to both sides first of all. So we have y squared plus k equals 2m, and if I subtract y squared from both sides, you can see here k is equal to 2m minus y squared. Question number 11. Megan grows potatoes. The box plot below shows information about the weights of Megan's potatoes, and Megan says that half her potatoes weigh less than 50 grams each. Is Megan correct? To give a reason for her answer. Well, clearly not, because the median is 57, as we can see here. And now for part B, Amy also grows potatoes. The box plot shows information about the weights of Amy's potatoes, and we have to compare the distribution of the weights of Megan's potatoes with the distribution of the weights of Amy's potatoes. Well, what we can do over here is compare the interquartile range and the median. So if we work out the median here, so the median here, that's equal to 57, we said that before, and here the interquartile range, that's equal to the upper quartile 65 minus the lower quartile 39. It turns out here we get, well, write that out in full, here we've got 65 take with 39, which is 26. And for Amy, the median, you can see here the median is 42, and the interquartile range, that's equal to the upper quartile 51 minus the lower quartile 35. Turns out here we get 16. Okay. So with that, we can now compare the distributions. So on average, Megan's potatoes weigh more than Amy's potatoes, and that's because Megan's 57 median is greater than Amy's 47 median, and the weight of Amy's potatoes are more consistent than the weight of Megan's potatoes. The interquartile range of 16 for Amy is less than the interquartile range of 26 for Megan. Question number 12. We've got this diagram this diagram which shows a triangle ABC, and ADC and DEB are straight lines. AD is equal to 4.4 centimeters and BC is equal to 8.6 centimeters, and those are shown in the diagram. E is the midpoint of DB, and the angle CDB, that's 90 as shown here, and the angle DCB, that's 40 degrees. We have to work out the size of the angle EAD. We'll call this angle over here that we need to work out theta. And we have to give our answer correct to 1 decimal place. Well, I've got a length here, and if I know this length, or this length, I can find out this angle. But for me to find out this length, I can use this triangle BCD to find out this total length, and knowing E is the midpoint, I can find out the length ED. So let's do that. If we consider the triangle BCD, we have over here BD, which is the opposite to this angle. We've got over here the 8.6, which is the longest side, opposite the right angle. That's the hypotenuse. So, therefore, what connects the opposite to the hypotenuse? That's sine. So we can see here that the sine of 40, that's equal to the opposite, BD, divided by the hypotenuse, 8.6. We wish to find out what BD is. BD, that's equal to 8.6 times the sine of 40. We'll leave it like this for now. And because E is the midpoint of BD, we can therefore conclude E is equal to 1/2 of 8.6 sine 40, which is 4.3 sine 40. So we'll add this to the diagram. So this length here is 4.3 sine 40. Okay, and what you can now see, if we consider the triangle AED, so considering the triangle ADE, we have over here the opposite to this angle theta, that's this 4.3 sine 40. Adjacent to this angle theta, we've got the 4.4. What connects the adjacent to the opposite? That's tan. So here we've got the tan of theta, that's equal to the opposite, 4.3 sine 40, divided by the adjacent. The adjacent here is 4.4. So if we work this out, 4.4 sine 40 divided by 4.4, that's 0. Let me just work that out again. So 4.3 sine 40 divided by 4.4, that's equal to 0.628, etc. So therefore theta, that's going to equal the inverse tan of 0.628. So if we work this out, the inverse tan of this, that's equal to 32.136, etc. degrees. So therefore to 1 decimal place, we have 32.1 degrees. Question number 13. Sakira invested £3,550 in a savings account for 3 years. She was paid over here 2.6 per annum compound interest for each of the first 2 years, and then for the third year she was paid R% interest, and Sakira had £3,819.21 in her savings account. At the end of the 3 years, we have to work out the value of R, give your answer to 1 decimal place. Well, here we've got we've got compound interest. So here we've got our original amount, 3,550, and the interest in the first 2 years, as a multiplier, that's 1 plus 2.6 over 100 to the power of 2. So this is the interest in the first 2 years over here. And we've got our original amount here. And we then have r percent interest in the third year. So we multiply this by 1 plus r over 100 to the power of 1 essentially. So this over here is the interest in the third year, all this over here. And at the end of all this, the amount we have is 3819.21. So this over here is the amount at the end of the 3 years. And our job is to find out what r is. So if we work out what this is, we have 3550 multiplied by 1 plus 2.6 over 100 to the power of 2. So here we get 3736.9998 multiplied by 1 plus r over 100, and this is equal to 3819.21. And if we divide by this quantity here, we have 1 plus r over 100, which is equal to 3819.21 divided by this, which is 1.02, etc. And if I subtract 1 from both sides, r over 100, so subtract 1, that's equal to 0.021, etc. And if I now multiply by 100, so times by 100, it turns out we get 2.19, etc. And to one decimal place, therefore, we have 2.2. Okay. Question number 14. Sadia is going to buy a new car. For the car, she can choose one body colour, one roof colour, and one wheel type. And she can choose from 19 different body colours and 25 different wheel types. The total number of ways Sadia can choose the body colour and the roof colour and the wheel type is 3325. We have to work out the number of different roof colours that Sadia can choose from. So what we have to do is multiply everything together. So here we've got 19 different body colour type. We've got over here as well 25 types. Okay, so this was this. We've got 25 different types of wheel. So this is wheel type. And we've also got roof colour, which is what we need to find. So let's just call this roof colour R. So this is roof colour. Okay. And the total over here turns out to be 3325. Okay. So this is the total number of ways. Okay. And our job is to find out the value of R. So here we've got 19 times by 25, which is 475. So we've got 475R equals 3325. So if I do 3325 divided by this, turns out we get 7. So R is equal to 7. Okay, so now for question 15, we have to expand and simplify 3x plus 2 lots of 2x plus 1 lots of x minus 5. So to do this, I recommend multiplying out the first two brackets. So here we've got 3x times by 2x, that's going to be 6x squared. And then we've got 3x times by 1, which is 3x. And then we've got 2 times by 2x, which is 4x. And then we've got 2 times by 1, which is 2. Okay, so what we have over here is this bracket multiplied by x minus 5. So here we've got 6x squared plus 7x plus 2, lots of x minus 5, and our job is to expand all this out. So here we've got 6x times by x, so that's 6x cubed. We then have 6x squared times by minus 5, that's minus 30x squared. And then we have 7x times by x, so that's 7x squared. And then we have 7x times by minus 5, so that's minus 35x. And then we've got 2 times by x, so that's 2x. And then we've got here 2 times by minus 5, that's minus 10. So now if we tidy all this up, it turns out here we've got 6x cubed minus 23x squared minus 33x minus 10. So that's our final answer. Question 16. Marek has 9 cards and there is a number on each card, and the numbers are 1, 2, 3, 4, 5, 6, 7, 8 and 9, and Marek takes at random 2 of the cards. He works out the product of the numbers on the 2 cards, and we have to work out the probability that the product is an even number. So we've got 9 cards in total over here to begin with, and of this 9 we've got 1, 2, 3, 4 even numbers. So for our first pick we've got 4 out of 9 which are even, and then for our second pick there's going to be 8 numbers left over, and if we've already chosen 1 even number there's going to be 3 even numbers left. Of course, even times by even gives an even. We're looking at the probability that the product is an even number. Another way we can think about this is we've got 9 numbers in total, and of those 9, 1, 2, 3, 4 of them are even. So again we have even, and of course even times by odd gives an even number. So if we select one number, there's going to be 1, 2, 3, 4, 5 odd numbers remaining. Even times by odd gives even. And another way of thinking about this is we've got 9 numbers in total. 1, 2, 3, 4, 5 of them are odd. So we've got 5 numbers which are odd. And odd times by even gives even. So there's going to be 8 numbers left if we choose one of these. And of those 8, 1, 2, 3, 4 of them are even. So these are the different ways we can find out the this is the probability of choosing an even number. So on the bottom we're going to get 72, and on the top we've got 12 plus 20 plus 20, which is 52. So if we simplify this fraction, it turns out here we get 13 over 18. So that's our probability of choosing an even number. So this is probability of choosing an even number. Okay. Question number 17, we've got A and B, which are points on a circle with centre O, and CAD is a tangent to the circle at the point A, and BOD is a straight line, and the angle ODA, that's 32 degrees, we have to work out the size of the angle CAB. You must show all your working. Well, we don't have to give a reason for each stage of our working, so we can just annotate on the diagram as we're going along. So first of all, we've got a tangent meeting a radius at 90 degrees. So here we've got 90 degrees. And angles in a triangle add up to 180. So 180 take away 32, take away this 90, that's equal to 58. So this angle over here is 58 degrees. And because from the center to a point we've got a radius, this length is equal to this length, and therefore we have an isosceles triangle. But before that, we can find out what this missing angle is here by considering this straight line. 180 take away 58, that's equal to 122. So this angle over here, this angle here, this is equal to 122. And to find out what this angle is, and also this angle, we recognize here we have an isosceles triangle. So 180 take away 122 and divide this by 2, turns out we get 29. So this angle here is 29 degrees. This angle here is 29 degrees. And our job is to find out what this angle is over here. And to do this, we have a right angle. So 90 take away 29, that's equal to 61. So this angle here is 61 degrees. And it's perfectly fine for you to show all you're working out on the diagram. Question 18. The histogram gives information about the heights in meters of the trees in a park. The histogram is incomplete, and 20% of these trees in the park have a height between 10 meters and 12.5 meters, so that's this missing bit here, and none of the trees in the park have a height greater than 25 meters. We have to complete the histogram. So we can first of all find out what the total area is. Okay, and remember, area represents frequency. So let's just write this down. Area represents frequency. So if we work out the area of this first rectangle, we have a base of 2.5, a height of 1.2. So sorry, here we've got 2.5. So here we've got 2.5 times by the height, which is 1.2. Turns out here we get 3. Here we've got a base of 2.5. The height here is 2. So it turns out here we have 5. Here we've got a base of 5. We've got a height of 2.3. No, we don't. We've got a height of 2.8. So here we get 14. And for the other one, we've got here a base of, well, 25 take away 12.5. That's 12.5, and multiply that by the height of 0.8. So times this by 0.8. Turns out we get 10. Okay. So 3 plus 5 plus 14 plus 10, that's equal to 32. Okay, so how is this useful? We've got 32 trees over here, and this is represented by 80%. The reason I know that is 20% have a height between 10 and 12.5, so the remaining 80%, that corresponds to 32 trees. And we want to find out how many trees is represented by 20%. So to work this out, we would have to divide by 4. 32 divided by 4, that's 8. So we have 8 trees, which is represented by 20%. So we've got a rectangle with area of 8. We've got a base of 2.5. So the height, therefore, 8 divided by 2.5, that's equal to 3.2. Okay, so here we have 8, and therefore the height over here is equal to 3.2. So if we draw this on, we have something looking like this. Okay. Question number 19. The diagram here shows a hemisphere with diameter 8.4 centimeters, and straight away when you see the word diameter you can find out the radius by dividing the diameter by 2. 8.4 divided by 2, it turns out that is 4.2 centimeters. So the radius is 4.2 centimeters of this hemisphere. We have to work out the volume of the hemisphere. Well, the volume of a hemisphere is half the volume of a sphere. So here we have 1/2 times by 4/3 times by pi times by the radius cubed. So we multiply by 4.2 cubed. And if we work this out, we have 1/2 times by 4/3 multiplied by pi multiplied by 4.2 cubed. Turns out we get 155.169, etc. And therefore, rounding this to 3 significant figures, we have 155 centimeters cubed. Question 20. D is equal to 1/8 of c cubed and c is equal to 10.9, correct to 3 significant figures, and by considering bounds we have to work out the value of d to a suitable degree of accuracy, giving a reason for your answer. So first of all we can find the upper and lower bounds of c. So the upper bound of c, that's equal to 10.95, and the lower bound of d, that's equal to 10.85. Sorry, the lower bound of c is equal to this. So from this we can find out the upper and lower bounds of d. The upper bound of d, that's equal to 1/8 times by the upper bound of c cubed. So here we have 1/8 times by 10.95 cubed. So here we have 1/8 times by 10.95 cubed. Turns out we get over here 164.1165469, and I recommend you write all the digits. And then the lower bound of d, that's equal to 1/8 times by the lower bound of d cubed. So here we have 1/8 times by 10.85 cubed. So if we change this over, turns out we get 159.6611406. Okay, and you can see over here both the lower bound and the upper bound to 2 significant figures round to 160. So let's just write that down. So therefore, because both the upper and lower bound of d round to 160, correct to 2 significant figures, we can conclude d is equal to 160. Okay, so for the next part of the question, we have a speed time graph for a train journey between 2 stations. The journey took 100 seconds as we see from here, and we have to calculate the time taken by the train to travel half the distance between the 2 stations. You must show all your working. Well, to do this question we can split this shape over here into small segments, and we need to recognize over here that the area under a speed time graph represents the displacement. So if we could split this up into 3 parts to make our lives a bit easier, so if we split it here and say here as well, this triangle over here has a base of 30, a height of, by the looks of it, 12, so 0.5 times by 30 times by 12, turns out we get 180. So this bit over here represents 180. Here we've got a height of 12, a base of 50, so 12 times by 50, that's equal to 600. And here we've got a base of 20, a height of 12, so that's going to be 120. Okay, so half times base times by height. So just work that out. A half times by the base times by the height. That's 120. Okay, so the total distance, that's going to equal the 180 plus the 600 plus the 120. Turns out here we get 900 meters. And we're looking at the time taken by the train to travel half the distance between the two stations. So over here you can see that half the distance, that's going to equal half of this 900, which is 450 meters. Okay, so hopefully this all makes sense so far. And we want to find out how long it'll take to travel 450 meters. Now, it took 30 seconds, so let's just write this down. It took over here 30 seconds to travel 180 meters, okay? So let's just write that down. It took 30 seconds to travel 180 meters, and therefore you can see from here 450 take away 180, that's 270. So you can see here we've got 270 meters left to travel. And if we consider this area over here, we've got 270, okay? And that is, we can consider this rectangle to find out the time it'll take to travel 270. And we can do that by considering the area. We want the area to be 270. We're figuring out the time, which is essentially the base. We know the height is 12. So we have here 270 divided by 12. That's 22.5. So from here we can conclude it takes 20, so let's just write this down on a new line. You can see here it takes 22.5 seconds to travel a further 270 meters. So what does this mean over here? 22.5 seconds, so here that'll be 50, so here we've got 50, 55, okay, so 22.5, that's going to be in between. So here we've got 30 plus 22.5, that's 52.5. So 52.5, well, we've got 50 over here, and then we've got 52.5, that's over here. Okay, so this over here, which I've shown in green, is the 270 meters which are left to travel. Okay, so hopefully that makes sense, and therefore the total time, so this over here takes us up to 52.5. So therefore the total time is 52.5 seconds. And now for part B, we have to compare the acceleration of the train during the first part of the journey with the acceleration of the train during the last part of the journey. So we've got three parts. We see here the acceleration is increasing, here the acceleration is decreasing, and we just have to put that down into words. So we've got constant acceleration for the first 30 seconds, and then we've got, so 30 seconds comes from here, and the last 20 seconds, which is from 80 to 100, we've got constant deceleration. And I think it's important that you actually say the word deceleration, because I think it's important you say the word constant, because we've got straight line gradients. Okay, Question 22. The number of rabbits on a farm at the end of month n is Pn, and at the number of rabbits at the end of the next month is given by Pn plus 1 equals 1.2 Pn minus 50. And at the end of March, there are 200 rabbits on the farm. We have to work out how many rabbits there will be on the farm at the end of June. So March, that's going to be, well, January, that's the first month. February, that's the second month. March, that's the third month, okay? So basically, March, that is P3, and we know that that's equal to 200, and we want to find out how many rabbits there will be at the end of June. So first of all, we need to work out how many there'll be in April, then May, then June. Okay. So in April, if we use this formula here, that's P4, that's going to equal 1.2 times by P3 minus 50. So we've got 1.2 times by P3, P3 is 200, minus 50. So if we type in 200 into our calculator, because we've got a recursive sequence, we've got here 1.2 times by this minus 50, so that's 190. In May, that's P5, so that's equal to 1.2 times by P4 minus 50, so we've got 1.2 times by 190 minus the 50, so we've got two lots of this minus 50. Sorry, I did that wrong. So here we've got two lots of 190. Should we just start this again? So we've got 200, then we've got two lots of this minus 50. So we've got 200, and then 1.2 lots of this minus 50. That's 190, and then substituting with 190 in, we get 178. And then in June, P6, that's equal to 1.2 times by P5 minus 50. So here we've got 1.2 times by 178 minus 50. That's equal to 163.6, which you can hopefully recognize. We can just round that up to 164 rabbits. Okay, and then considering the result in part A, we have to suggest what will happen to the number of rabbits on the farm after a long time. So if we continue that sequence, so we've got 1.2 times by this minus 50. You can see over here eventually the number of rabbits will die down. Okay, so there won't be any rabbits left as each month the number of rabbits is decreasing. Now for question 23, we've got a diagram which shows a parallelogram, as we see here, and the area of the parallelogram is greater than 15 centimeters squared. We have to show that 2x squared minus 21x plus 40 is less than 0. Well, for this parallelogram, we can split this up into two parts. So we've got this part here and this part here, and this angle over here is going to be 150 degrees. This length opposite this is going to be 2x minus 1, the parallel, and this over here is going to be 10 minus x. And from this we can find out the area of one of these triangles, and multiplying it by 2 will find out the area of the parallelogram. So if we do that, we've got two lots of, well, the area of one triangle, that's 1/2 AB sine C. So we've got 1/2 times by 10 minus x times by 2x minus 1 times by the sine of 150. And this must be greater than 15 centimeters squared. So, well, if we deal with the two lots of 1/2, well, sine 150, So 2 times by 0.5 times by sine 50, that's equal to a half. So here we've got 1/2, lots of 10 minus x, lots of 2x minus 1 being greater than 15. So here we've got 10 minus x, lots of 2x minus 1 being greater than 30. If we expand and simplify, well, 2x times by minus x, that's going to be minus 2x squared. 10 times by 2x, that's 20x, and then minus x times by minus 1, that's minus 1x. So we have over here 21x. Does that make sense? So here we've got so we've got 10 times by 2x, which is 20, yeah. So here we've got 21x, and then 10 times by minus 1, that's minus 10. And this is greater than 30. And if we rearrange taking everything over to one side, 2x squared minus 21x plus 40 is less than 0. Okay, and now for part B we have to find a range of possible values for x. So we have to solve this inequality, in other words. So if we solve this inequality, first of all, we can find the critical values by replacing the inequality sign with an equal sign. So we've got 2x squared minus 21x plus 40, which is equal to 0. And if we factorize this, well, here I need two numbers which multiply to give 2 times by 40, which is 80, which add to give minus 21. You'd find these two numbers to be minus 16 and minus 5. Okay, so we can rewrite this as 2x squared minus 16x minus 5x plus 40 equaling 0. And now if I split this down in the middle, if I factorize this left bit, I've got 2x lots of x minus 8. I want an x minus 8 over here, so you can see here minus 5 lots of x minus 8 gives minus 5x plus 40. So if I group the terms together, we've got here 2x minus 5 lots of x minus 8 equaling 0, and therefore for your critical values we've got x equaling 2.5 and 8. So if we draw a quick sketch to help illustrate what's going on, so if I draw a sketch like so, we've got y, we've got x, and we've got our critical values here at 2.5 and 8. So if we draw a quadratic inequality, we've got something looking like this, and we're looking at the region where it's below 0, so that's everywhere here. So here we had the 2.5 and here we had the 8. So therefore the range of values we have 2.5, which is less than x, which is less than 8. Question number 24. We have here a square ABCD and it's transformed by a combined transformation of a reflection in the line x equals minus 1 followed by a rotation, and under the combined transformation, two vertices of the square ABCD are invariants. What does this mean? It means here that two vertices don't change, okay? So we have to describe fully one possible rotation. So I think a good place to start this question is by reflecting this square in the line x equals minus 1. So if I do that, let's draw the line x equals minus 1, like so. So here we've got the line x equals minus 1, and if I reflect this shape, the shape goes to here. Okay, so let's just join up all these points together like so. Okay, so here this point goes to this point, so we'll call this A dash. This point goes to this point, call it B dash. this point goes to this point, call it C dash, and this point to this point, call it D dash, okay? And I think at this point it'll be a good idea to actually trace this shape. So here's my tracing paper, I don't know if you can see it, but if I trace this shape, we can then figure out possible positions of our of where the shape will lie after the rotation. Okay, so I think that's probably the best way about going this question. So here we've got A dash, B dash, D dash, and C dash. Okay, so let's think about what we can do. I'm going to use a compass just to keep the paper still, otherwise it's quite slippy. But so we want 2 points to remain the same over here on this shape. So if we think about what we can do, well, potentially we can, okay, let's move this down a bit. So potentially what we can do is, if I rotate, so this is 90 degrees followed by 180 degrees, you can see here D, that's remained the same, C, that's remained the same, but here A and B have moved. Okay, and that was by rotating it about this point here. So potentially one possible way we can do this, if I just draw it in purple, we can have this situation over here where the shape has now moved over here. So this is one possible rotation we can have. Okay, so here D and C haven't changed, but A has moved from here to here, so call this A double dash, and B has moved from here to here, call this B double dash. And what you'd find here is we had a rotation, so let's just write this down. Here we had a rotation by 180 degrees with center -1, 2. Okay, so that's one possible thing we can do. Let's see what else we can do. So if I grab my tracing paper again, one other thing we can do is, well, this time we can have A and B fixed presumably. So if I do that, let's rotate it. So that's 90 degrees, 180. Okay, so let's move it. Okay, so from, if we had a center of -1, 2, this point moved to this point, and that was with D and C remaining fixed. So if I have my center being here this time, that will ensure A and B are fixed, and then D and C will move. Let's try that. Okay, so that's 180 degrees, like that. So that's one thing that works. You see here, A's fixed, B's fixed, but C and D have moved. So that's another one we can have. If I just draw this out, we have over here this second possibility. So this is another possibility of, so C goes over here, so C double dash, and D goes over here. So D from here goes to here, and C goes from here to here, and A and B remain fixed after the two transformations. So what we'd have over here then is a rotation by 180 degrees with center -1, 4. Okay, so that's the one in green. And if we think about what else we can do, so we've got this over here. Is there any other ways we can fix these? Well, let's rotate about the origin. Let's see what happens. So if I rotate about the origin, I've got here. Okay, that doesn't do anything for me. But what you can see here this is interesting. So if I rotate it about the origin by 90 degrees, the new shape will go over here. But if you think about it, D dash and D and B dash are in similar positions. So maybe if instead we rotate it about here, so if I rotate about -1, 0, like so, B has remained fixed, D has remained fixed, but then C over here has moved to this point here, and then A over here has moved to this point here. So that's one possible combination. So let's just grab a different color felt tip. So essentially what I'm saying here is, after the transformation you've got this situation where B and D remain fixed, and what we saw then was when I rotated it about this point -1, 0 by 90 degrees clockwise, C went over here, so let's call this C double dash, and A went here, so A double dash. Okay, so that's another one we can have. We can have as well a rotation, so let's just write this down. We can have a rotation by 90 degrees clockwise about -1, 0. Okay, so that could work as well. So let's think of another one we can do as well. So let's grab a different color. So if we start here, so for that one we did that ensured B and D remained fixed. So let's try to keep A and C fixed over here. So if I do that, so this was over here, 1, 2, so this one got me to there. So if I think about what else I can do, so basically I want this to end up, what I want is essentially A to remain fixed and C to remain fixed. So essentially I want this over here, going from here to this traced one. So I want D dash to go here this time. No, sorry. Actually, could that work? Well, so if I grab my tracing paper, let's go over it again. So before I rotated it there, let's see if I rotate it. Okay, so that was 2 lines below this, so 2 lines above. Let's try here to see what happens. So if I rotate, I've got 90, 180, and then here 270. Yeah, so B goes over here, D goes over here, that's what I wanted, and then A and C remain fixed. So that works if I rotate about here. So one other combination I can have is this one over here. So if I draw it in, I don't know if it's clear or not, in orange. So what I can potentially do over here is have A and C remaining fixed, but then this B coordinate goes here. So here we've got B double dash, and here this D coordinate will go here instead. So here we can have D double dash. So what was that? That was a rotation 270 degrees clockwise by -1/6, and instead of having a 270 degrees clockwise, we can have a 90 degrees anti-clockwise. Okay, so that's another way we can phrase that. Quite a difficult question to understand, I think, but hopefully that helped. Okay, so yeah, I've written over here then 4 different possible answers we can have, and I imagine you would have got a mark for the reflection first, and then thinking another mark for stating one of these. Quite a harsh question. Question 25. The straight line L has equation 3x plus 2y equals 17, and the point A has coordinates 0, 2, and the straight line M is perpendicular to L and passes through A. The line L crosses the y-axis at the point B, and the line M and the lines L and M intersect at the point C. We have to work out the area of the triangle ABC. And I think at this point it will be a good idea to draw a quick diagram. So, if we do that, well, first of all, we need to draw this straight line. So, if we consider the line L, that has equation 3x plus 2y equals 17, and if we rewrite this in the form y equals mx plus c, so if we rewrite this in the form y equals mx plus c, the m over here tells us the gradient, and the c over here tells us the y-intercept. The reason I want these is because that will allow me to, well, that will help me progress in the question. And if I know the gradient of this line L over here, I can use the fact that M and L are perpendicular to each other to find the gradient of M. So if I rewrite this in the form y equals mx plus c, so here we've got 2y equals minus 3x plus 17, and therefore y is equal to minus 3x over 2 plus 17 over 2. And therefore the gradient of L, that's equal to minus 3 over 2. Hopefully that makes sense so far. And if we consider M, well, actually before that, we can find out what happens when x is equal to 0. When x is equal to 0, y is going to equal, well, here we've got 0 plus 17 over 2. And when y is equal to 0, we've got x, which is equal to 17 over 3. Okay, so we were told that the line L crosses the y-axis at the point B, so therefore here the coordinates of B are 0 and 17 over 2. Okay, so let's draw a diagram to help illustrate what's going on so far. So we've got here our coordinate axis, like so. We've got y here, x here. Okay, so we've got the line L. I'll draw that in blue. So that looks something like this. It doesn't have to be 100% accurate. So this is the line L, and it crosses here at the point 17 over 3, 0, and it crosses the point here, the point B over here, with coordinates 0, 17 over 2. Okay, so let's just call this point D over here. Okay, so this point here we'll call D. Okay, and we've got this point A that's over here somewhere. Again, doesn't have to be 100% accurate. A has coordinates 0, 2. Actually, let's just make life a bit easier for ourselves. Let's put A over here. So this is the coordinates A, 0, 2. Okay, so how does that help us? Well, we know that the line M is perpendicular and it crosses C. So here is where we're going to have our line M. Okay, and they cross at this point C over here. Okay, so we can find out the coordinates of C, and we need to figure out the area of this triangle here. Okay, so to find out what the gradient of M is, we can use the fact that they are perpendicular to each other. So the gradient of M, that's going to equal the negative reciprocal of the gradient of L. So we have minus 1 over the gradient of L, which we said was minus 3 over 2. So if we work this out, we get 2/3. Okay. And we know that it crosses the y-axis at the point 2. So therefore, M has equation y equals 2x over 3 plus 2. Okay. So let's just write this down. We've got here y equals 2x over 3 plus 2. And here we've got minus 3x over 2 plus 17 over 2. So this is what y is equal to. Okay, so we can find out the coordinates of C by essentially solving this equation, call it 1, with this equation, call it 2, simultaneously. So let's just write that down. So we can solve those equations simultaneously, and the way we can do that is setting them equal to each other. So here we've got minus 3x over 2 plus 17 over 2, and this is equal to 2x over 3 plus 2. Well, if we gather all the x's on one side, so here we've got 2 over 3 plus 3 over 2, so that's 13 over 16. So here we've got 13 over 6x, and then if I take 17 over 2, so if I take 2 from 17 over 2, I get 13 over 2. Okay, so if I multiply this by 6 and then divide by 13, turns out x is equal to 3. Okay, so x is equal to 3, that's the x coordinate of C. And the y coordinate we can find by substituting into either equation. So when x is equal to 3, y is equal to 2 thirds lots of 3 plus 2. So here we've got 2 plus 2, which is 4. So the corresponding y coordinate is 4. So if we extend this out a bit and redraw the triangle ABC, so if I draw the triangle ABC, something like this, we've got C with coordinates 3, 4. We've got B with coordinates 0, 17 over 2, so this is B. And we've got A with coordinates 0, 2. And we want to find out the area of this triangle. So the area is equal to 1/2 times by the base times by the height. Now, the base over here is going to be this distance here. So that over here is going to equal 17 over 2 minus 2, which is 13 over 2. So here we get 13 over 2. And the height over here is going to be, if I work this out, the height over here is going to be, well, 3, because we're going from x equals 0 to x equals 3. So we have 1/2 times by 13 over 2 times by 3. So it turns out here we're going to get 39 over 4 units squared. Okay, so that is our final answer.